Okay, so all of the examples we've looked at so far with finding values have asked us to find the value of z. But one thing we could look at for is what if we want to find the value of a normally distributed random variable x? So remember before, our steps for finding the area under the normal curve when given a value of x, we first would find the values of the mean and standard deviation and use those to convert x to a z value, and then use the z value to find area under the curve. So if we want to go the other way, we already know how to find our z given the area, but then we just do the next step in reverse also. So we rearrange the z-score formula using algebra to solve for x. So we start out z is equal to x minus mu divided by sigma, and then we do a little bit of algebra, so multiply by sigma on both sides, and then add the mean to both sides to get x by itself, and we end up with the formula x is equal to z times sigma plus mu. So you have two choices. You can either memorize this formula in addition to the z-score formula, or you can just know the z-score formula and then solve backwards for the other formula every time. The choice is yours. Either way though, once you have the z-score, if you have the area, then you still do the same process. So you find the given use the given area, find the corresponding z-score, that's what we've already done. And then use the values of z, the mean and the standard deviation, to find the value of the random variable x using the formula x is equal to z times sigma plus mu. So sometimes you might hear x called the raw score, or just the value. Or it could be just asking you to find something in terms of the context of a problem. So let's look at an example. So a veterinarian records the weights of cats treated at a clinic. Weights are normally distributed with a mean of 9 pounds and a standard deviation of 2 pounds. Let's find the weights x corresponding to z-scores of 1.96, negative 0.44, and 0. So using our formula, we know that x is equal to z times sigma plus mu. Or if we're talking about a sample data, x is equal to z times s plus x bar. So in this case, we know we have mu equal to 9, sigma equal to 2. So then, to find the x weight, so the weight of the cat x, corresponding to a z-score of 1.96, we just use the formula x is equal to 1.96, so that's our z, times our standard deviation of 2, plus the mean of 9. And so we do that and we get 12.92 pounds. Similarly, for a z-score of negative 0.44, it's the exact same process. So x is equal to negative 0.44 times 2 plus 9. And we do that and we get 8.12 pounds. So a cat that has a z-score of negative 0.44 weighs 8.12 pounds. And then similarly for z equals 0, then x is going to equal to 0 times 2 plus 9, which just equals 9 pounds. Although realistically, you don't have to do the formula in this case because of the fact that we know that a z-score of 0 corresponds to our mean. So you don't even have to really use the formula for that one, but you can use the formula. It'll still work. Let's look at another example going all the way now. So scores from the California Peace Officer Standards and Training Tests are normally distributed with a mean of 50 and a standard deviation of 10. An agency is only going to hire an applicant with scores in the top 10%. So we want to know what's the lowest score that you could earn on that test and still be eligible to be hired by the agency. So same idea. So we know they're going to hire somebody in the top 10%. So if we sketch our z distribution and we put our mean on here of 0, then top 10% means it's going to be 10% of the area to the right. So 0.10 to the right, which then means we need to figure out area to the left. So we know for area to the left, it's just going to be 1 minus 0.10, which gives us 0.90 to the left of that value. So from here, we know any exam that's in the top 10% is going to be some score above the 90th percentile. So we need to find the z-score first that corresponds to that. But notice in this case the lowest score, this is talking about the score on the test itself. So this is not talking about the z-score. We want to find the x value. So, but to get there, we first have to find the z-score. So we know we're looking up 0.90 on our z-score table. So we go and look. 0.90, we have to be on the positive side because it's above the mean. And so we're looking for 0.90. And it is not there. We have the two values that immediately are closest to it are 0.8997 and 0.9015. So those are the two values that surround it. In this case, you could do the subtraction again. So you could do 0.8997 minus 0.9, 0.9015 minus 0.9, ignoring the signs to see. But we can also think about it logically. 0.8997 is definitely going to be closer because it's only off in the last digit, essentially. Whereas the 0.9015, we're 15 away. 10 thousandths away. 8997, we're 3 10,000ths away. So 8997 is definitely our closer value. So we go back, we get that z-score of positive 1.28. So we know z is equal to positive 1.28. But then we've got to find the x value from this also. So to do that, we just use our formula. X is equal to z times sigma plus mu. So in this case, x is equal to 1.28 times our standard deviation of 10 plus the mean of 50. And so when we do that, we get x is equal to 62.8. Rounding to the nearest point, you need to get about a 63 on the test. One last thing to talk about is Pearson's index of skewness. So we know we can use the empirical rule and we can convert to z-scores and everything if we have a normal distribution. So normal distributions we know are always going to be symmetric. So a formula that we can use to calculate skewness of a distribution as one way to tell if we might have a symmetric distribution or not is to use Pearson's index. And so Pearson's index P is equal to 3 times the mean minus the median, and that quantity all divided by the sample standard deviation S. So if we get a p-value that's either less than -1 or greater than 1, our distribution is skewed and therefore it cannot be normal. So we cannot use any of the stuff we've talked about in this section. And so we would have to look at other techniques. So remember, if p is less than -1, p is greater than 1, then you have a skewed distribution.